Welcome to Hollow State Design's short video on how to wind a center tap toroid. This video was specially made for users of the Hollow State Design VFO kit, but it's applicable to anyone who needs to make a center tap toroid inductor. The toroid supplied in the VFO kit is a T68-2, meaning it has an outside diameter of 0.68 inch and is made from Type 2 material. You can tell that from the red color of the toroid. Start by straightening out the enamel wire provided and bending it in half to locate the center point. The next step is to remove about a ½ inch of the enamel from the wire center. Now you can do this one of several ways. You can burn it off by using a blob of melted solder on the end of your iron like you see here. Pass it over the wire back and forth until the enamel burns off. You can also use a flame from a lighter or torch. This usually leaves a black residue that you need to clean off. Or you can use a small square of fine grit sandpaper, around 200 grit. Fold it over on the wire, and while squeezing the wire, pull the wire through the sandpaper several times until the enamel gets rubbed off. When done, make sure most of the enamel is removed for about a ½ inch. It doesn't have to be perfect. Then grab the center of the bare copper portion with the tip of a needle nose pliers and pull it tight. Then give it a full circle twist like this. It should look something like this. The loop will provide a connection point for the center tap wire. Some builders prefer placing the toroid in a vise, clothespin, or other clamp to hold it while you thread the wire. I just hold it with my hand. Start with placing the center tap loop on the outside of the toroid and winding the loose ends of the wire through the hole away from the center tap. In this photo, there are 3 turns on each side of the tap. Remember, each time the wire passes through the toroid hole, it counts as a turn. When finished, it should look like this with a total of 14 turns. 7 turns on each side of the center tap. Spread the turns so they occupy about 2/3 of the toroid. If you have a way to measure the inductance, such as the almost all digital LC meter, you can check your work. The measurement on the left is with 14 turns, and it measures about 1.13 microhenries. I added a turn, 15 turns on the right, giving 1.25 microhenries. Both values will work fine in the circuit. Then cut both leads to about 1 inch. And then remove about 3/8 of an inch of enamel from each wire. And then tin the wires, including the tap point loop wire. When done, the finished inductor should look close to this. Congratulations!